Welcome back. In this video, we're going to go over section 9.3, which is about how you can use a quadratic formula to help you solve quadratic equations. So many of you are probably already familiar with the quadratic formula. If so, that's fine. If this is completely new to you, that's also fine. So one of the nice things about this is that after completing this section, we'll have a nice kind of mechanical procedural way to solve any quadratic equation you want. So you probably noticed when we were working on completing the square to solve equations like ax squared plus bx plus c equals 0, that it was a uh, kind of tedious in a way, the same sequence of steps over and over. You'd move the constant over to the other side. You would divide by the leading coefficient to make it so the leading coefficient was 1. Take a look at the number next to the x, take half, square that, add that to both sides, factor the left-hand side, and so on and so forth, right? It was a lot of the problems proceeded in the same basic way. So what we're going to do is try to do this just kind of once and for all for a kind of generic quadratic equation happens. So let's say that we've got this equation, ax squared plus bx plus c equals 0. And for this, we're going to just go ahead and assume that a is not 0. After all, if a were 0, we would just have a linear equation, right? And we know how to solve those. So we can assume that a is not 0. So then the steps that we follow to solve a quadratic equation by completing the square are to divide throughout by a to make it so that the leading coefficient is just a 1. 0 divided by a is still 0. And then we move that constant over to the right side, or subtract it from both sides. So, and leave a little hole, right? We have to leave that little hole in there. Okay, so there's that. So now we take a look at the number next to the x. This is the part where we take half and square it. So let me try one with numbers in it just to remind you how this goes. You add x squared plus 6x plus 11 equals 0. Here, I just made this up, okay. At this point, we took the 11 to the other side. We took a look at the 6. Half of 6 is 3. 3 squared is 9, so that's why we would add 9 to both sides. Okay, take a look at the number next to the x, take half, square that, add that to both sides. All right, if it's an odd number in the middle, you saw that takes a little bit more care. So I just made this up. X squared plus 3x equals 51. So here, to take half of 3, don't do 1.5, okay? Half of 3 is going to be 3 over 2. And just basically stick a 2 underneath, right? And then we're going to square it. This will give us 9/4. To take half of a number for this purpose, it's easiest just to divide by 2, which is the same as taking half, and don't turn it into a decimal. So here, taking a look at our b over a, if we wanted to take half of that, we would have b over 2a, double the denominator to make half, and then square it. This would be b squared over 4a squared. We're going to add b squared over 4a squared to both sides. And this may be already starting to look familiar to you, right? If you have some experience with the quadratic formula. So there's that. So that's where the constant term comes in. Took a look at the number next to the x. We took half of it, so basically just doubled the denominator, then squared it. And that's what gave us this pink thing. All right, so then doing that, this is the part now where we're going to factor. So then the left side is x plus b over 2a. The b over 2a, where did that come from? Remember, it's half the number next to the x, or the square root of that constant term. When you are over here with x squared plus 6x plus 9, that factors x plus 3 squared, right? Where did the 3 come from? It's half of 6, or equivalently, square root of 9. Here, we have b over a, so we'll have b over 2a. Now, for the right side, we're going to need to get a common denominator so that we can get that arithmetic done. So the denominator in blue is a, the denominator in pink is 4a squared. So we're going to take that left fraction and multiply the top and bottom by 4a. Let me rewrite that a little nicer so that it looks more like what I'm doing. So, okay. All right. So then next, all right. So there's a little mistake in here that I need to go back and fix. You probably already saw that. In here, let's show where that is. When I had C over A here, when I copied it over to the other side, somehow I turned that into a B over A into C over A. And so I need to go back and fix that. On the right side here where you say C B over A, I'm going to need to change that into C over A. And so that's going to happen right now. So this, we should have, all right. So sorry, Zoom crashed again. So back to where we were. All right, so there we go. So I've fixed my mistake. So we should have minus C over A on the right side before a minute ago I had B over A, which was wrong. So I fixed that now. And so we factored the left-hand side. I won't do anything to it in this next step. In here on the right side, we now have a common denominator of 4A squared. And so we can add and keep the same denominator. Now at this point, we can take the square root of both sides. And so let's do that. We'll have x plus b 2a is equal to plus or minus the square root of everything on the right. As I copy this over, that minus 4ab plus 4ac plus b squared, I'm going to rewrite that as b squared minus 4ac. If that's okay with you. And then down below 4a squared. So now it's, I'm sure, really starting to look familiar. So then we'll have isolating the x minus b over 2a plus or minus. Let's split this radical into two parts. That'll be b squared minus 4ac in the top. Down below, the square root of 4a squared. Only two more things to do. That minus b over 2a still here. We'll have the same radical, b squared minus 4ac on top, but down below the square root of 4a squared will give us another 2a. And then finally, combining these terms, and with minus plus or minus the square root of b squared minus 4ac all over 2a. And that there is the quadratic formula. So some steps to follow, but we made it to the end. That's it. A couple of questions and comments. A natural question is, do I need to be able to reproduce this? In a sense, you do. It's a good idea to be able to know how to complete the square, and really that's all that is. What makes that perhaps look harder is the fact that it's A's, B's, and C's instead of numbers, as we had done up here, but it's built out of the same process. When does it work? When can you use the quadratic formula? You can use the quadratic formula to solve any quadratic equation, just as we saw completing the square can be used to solve any quadratic equation, and this is basically completing the square. The other thing worth mentioning is, and this will help save you some points, is this fraction, the numerator is all minus b plus or minus, and then that root over 2a. A common mistake people make is to just have the 2a underneath the root part sometimes, or sometimes just underneath the minus b. That fraction bar goes all the way across. You need to have the minus b plus or minus that big old root. All of that is in the numerator, and then the entire denominator is the 2a. Okay, all right, so that's how that works. And what's next to do is to try some examples where we apply the quadratic formula. So to do that, kind of the main thing really is then just to know what A, B, and C are. So for this one, A is equal to 3, B is equal to -5. Be very careful that you pick out the right value. There's a minus sign there. We developed our formula with AX squared plus BX Okay, that's 3 times now. All right, so we're back. So, and then the last, the c is equal to 2. Okay, so to read this right, we need to look at this as plus negative 5y. So make sure that you're reading that b as negative 5 rather than positive 5. Okay, so then our formula, minus b plus or minus, and then underneath the square root, b squared minus 4ac over 2a. Okay, so then putting in our values for this problem, our b was negative 5, so the opposite of negative 5 will give us 5. Okay, underneath the root sign, we have b squared. Negative 5 squared will be 25. Minus 4 times the a, which was 3, times the c, which is 2. And then down below, 2 times a is 3, so 2 times 3 is 6. Okay, so now simplifying the radical, we'll have 5 plus or minus. And then in here we have 4 times 3 is 12, times 2 is 24. That's 25 minus 24. And that's over 6. 25 minus 24 is 1. 5 plus or minus the square root of 1 over 6. That's the same as 5 plus or minus 1 over 6. 5 plus 1 is 6. 6 over 6. 5 minus 1 is 4. That will be 4/6. 6 over 6 is 1. 4 over 6 is 2/3. So our two solutions are 1 and 2/3. Okay, so one thing that's important to note here is that for our answers, we got integer answers or rational number answers. Whenever you end up with rational number answers, you could have factored. Of course, it's over now, so there's no need to do so, but just so that you know, we could have factored that in the first place, and it might have been a little faster. Okay, let's try this next one. We've got a squared minus 2a is equal to 15. I'm going to start by collecting all of the stuff, non-zero stuff on